Right now, beneath 8 United States, there is this hidden water body. And it's roughly the size of a small ocean, and it's just vanishing.
Yeah, completely disappearing.
Right. And the terrifying part isn't just that it's disappearing, it's that the maps you see on the evening news, the ones with those neat little red and yellow polygons warning us about drought, they are fundamentally lying to you about what the actual problem is.
They absolutely are.
I mean, you unfold a map or you look at your weather app and you see a solid blue line snaking across a state, and your brain instantly categorizes it like, okay, there is a river. Or you see a shaded blue blob and you think, ah, a lake. It gives us this really deep, comforting sense of objective precision.
Well, it creates a binary illusion, right? We
Yeah.
want the world to be clean. We want to know exactly where the wet part ends and the dry part begins. But when you step out of that cartographic fantasy and get into the actual physical reality of hydrogeology, especially right now, in the middle of this catastrophic compound drought we are living through in 2026, that flat map is a really dangerous oversimplification. I mean, we are relying on two-dimensional drawings to diagnose a three-dimensional, highly pressurized dying body.
And that brings us to why we're here. Welcome to this deep dive. Our mission today is to just completely tear down and rebuild your fundamental understanding of water, of drought, and ultimately of what it is actually going to take to ensure the survival of the American breadbasket.
Because if we keep looking at water as dead, flat matter on a page,
Yeah.
we're going to lose the ability to feed millions of people.
We really are. So to guide us through this, we are dissecting this incredibly dense, multidisciplinary set of material. It's titled The Chug of Water, Rebuilding the Continental Hydrologic Circuit. And it's fascinating because it challenges the very geometry of how we manage resources.
Right. The core argument here is that the Platte River, for example, is not just a surface river.
Mhm.
And the Ogalla Aquifer is not just an underground tank. They are expressions of one massive, interconnected hydrologic field body. And that body is currently experiencing a physiological failure.
Okay, let's unpack this, because to even begin understanding this field body, we have to completely redefine our terminology. The source material uses this ancient Hebrew concept to reframe our modern crisis. The word is chug, spelled C-H-U, circumflex G.
Yeah, chug.
Historically, it translates to circle or circuit, compass, vault, or horizon. But we aren't talking about a circle like a geometry student draws with a compass on a flat piece of paper, right?
Far from it. A flat ring drawn on a page is entirely static. I mean, it has no depth, no pressure, no life at all. The chug represents a bounded relational field. It's a living circuit of relation.
Okay.
So if you really want to understand water, you have to track it moving continuously through this pressurized circuit, sky to snow, snow melting into the river, river flowing into the reservoir.
And then the reservoir feeding the canal, which seeps into the soil, percolating down into the aquifer.
Exactly.
Yeah.
And it absolutely does not stop there, which is where our modern management gets it so incredibly wrong. That aquifer pushes water back up into a stream.
Right.
The stream is diverted to irrigate a crop. The crop transpires moisture back into the atmosphere. The atmosphere gathers it, builds a storm, and drops it right back onto the land.
That continuous loop,
Yes, that continuous, unbreakable, three-dimensional loop is the chug.
which just completely shatters how we use the word drought. I mean, in everyday conversation, a drought is just, less rain.
Right, you look up, it's sunny for too long, you declare a drought.
Yeah. But through the lens of the chug, drought is the failure of the local circuit to close. The global water cycle is fine. The Earth hasn't vented its oceans into outer space. The water still exists.
It's all still here.
But the regional body, like the specific geography of the Great Plains, is spending vastly more water than it receives back. It's bleeding out.
That's a great way to put it.
I was trying to visualize this failure of the circuit, and the best analogy I could think of is the human cardiovascular system. Think about a standard flat map, like a kindergartner's stick figure drawing of a person. You've got a blue line for a vein, a red line for an artery.
Yeah, very basic.
Right, and if someone has a massive heart attack, that stick figure drawing doesn't change, just says arm, leg, chest.
Oh.
But the chug is like looking at a functional, real-time MRI of a beating circulatory system. You see the blood pressure dropping, you see the capillaries starving for oxygen, you see the volume of fluid actually draining away.
That is precisely what we're looking at when we see a dry riverbed. When a drought monitor map highlights a county in dark red, you aren't just seeing a lack of rain.
You're seeing a collapsed capillary.
Exactly. You are seeing a collapsed capillary in the larger cardiovascular system of the continent. The internal pressure of the Earth has literally failed.
And here is where the material takes a turn that I genuinely did not see coming. To explain exactly how this internal pressure works, like how water actually behaves as a living field rather than just dead stuff, we have to zoom all the way down, past the soil, past the microscopic pores of sand, all the way down to the quantum physical level.
Yeah, it demands that we accept this principle of feel before object. Most of us were taught a very mechanical Newtonian version of the universe in grade school.
Oh, yeah, definitely.
We were taught that reality is built out of these tiny, hard, dead building blocks.
Right, the classic microscopic Legos, like the atom is a tiny sun and the electron is a solid little marble orbiting on a fixed track.
But physics abandoned that model a century ago.
Ugh.
Matter does not appear as dead blocks. It is field-structured.
Huh.
A hydrogen atom is a probability cloud.
A cloud, right.
Yeah, photons of light are not little solid pellets. They are excitations of an underlying electromagnetic field. When you drill down to the absolute limits of physical reality, everything is a gradient of fields interacting.
Now, I have to stop you there, because when I hit this section of the research, my immediate reaction was, wait, we are supposed to be talking about the survival of the American breadbasket. How does a quantum probability cloud have absolutely anything to do with a dried-up cornfield in Nebraska?
It seems like a leap.
It really does. And then they introduced this concept called the Gertzenstein mechanism.
Right. What's fascinating here is that the Gertzenstein mechanism is the ultimate proof of concept that reality is not divided into sealed-off kingdoms.
Okay, so what is it exactly?
In physics, it describes a phenomenon where electromagnetic waves, under specific magnetic field conditions, can actually couple into and generate gravitational waves. Electromagnetism and gravity can interact.
But physicists will be the first to tell you that in a laboratory, this effect is unimaginably weak. I mean, we are talking about microscopic conversions. Why anchor a massive hydrological thesis on a microscopic anomaly?
Well, because weak is a statement about scale, not a statement about reality.
Oh, that makes sense.
If you are measuring the Gertzenstein effect in a 1-meter vacuum tube in a lab, of course it's negligible. But when you scale that interaction up through enormous magnetic fields, massive populations of photons, the vast curvature of the Earth, and geological timescales, it becomes structurally meaningful. It builds up. Exactly. It proves that energy, mass, light, and gravity all participate in one unified single system.
So to be clear, the argument isn't that laboratory gravitational waves are literally pushing the Platte River downstream?
No, definitely not. The point is to provide a bridge principle. If the fundamental nature of the universe is that field creates gradient, gradient creates motion, motion creates structure, and structure stores energy.
Then water is doing that.
Yes, water is the ultimate macroscopic expression of that exact quantum reality. Water is not dead mass, it is polar mass.
Let's ground that in the physical dirt for a second. An H2O molecule has a positive pole and a negative pole. It is fundamentally electromagnetic.
Exactly. And because of that polarity, electromagnetism governs how water behaves. It is why water molecules stick to each other. Right. It's why water beads up on a leaf. And crucially, it is why water wicks deep into the microscopic pores of a subterranean rock formation against the pull of gravity.
Wait, really? The wicking is electromagnetism?
Yes. That capillary action inside an aquifer is pure electromagnetism at work.
But then gravity takes over on the macro scale, pulling the snowmelt down the side of the Rocky Mountains. Pressure dictates how that water flows when it's buried under millions of tons of limestone. Density creates buoyancy.
And when you combine the microscopic pull of electromagnetism with the macroscopic crush of gravity and pressure, you don't get a flat blue line on a map.
You get the chug.
You get a wildly complex three-dimensional energetic circuit. You get the chug.
And because it is this complex 3D internal field, our standard geometry, like the literal math we use to measure our world, fails to accurately describe it. We cannot measure a living water system from the outside.
Right. Think about a standard geometric shape, like an octahedron. It looks like an 8-sided die, or 2 pyramids glued together at their square bases.
I can picture that.
Standard exterior geometry counts the shape from the outside. It has 8 flat triangular faces, 6 pointy vertices, and 12 edges where the faces meet. 8, 6, 12.
But if you measure a water system that way, you are only doing what the source calls a shell count. You are only measuring the husk.
It's an illusion of completeness. The philosophical rule we have to accept is that an absolute outside does not exist. Every outside boundary you see is only the inside of a much larger field.
Okay.
Therefore, you cannot truly measure a volume without acknowledging its center. The center is the condition that makes the measurement possible.
I want to make sure we visualize this clear. Let's use an apple instead of an abstract octahedron.
Good idea.
If I use standard geometry to measure an apple, I am only mapping the red skin, I'm counting the surface area. But the interior field logic says that measurement is fundamentally flawed because it ignores the core.
Right. Because without the core.
Exactly. If the core of the apple rots and collapses, the skin caves in. The red boundary only exists because it is being held up by the hidden volume underneath it.
That is a perfect translation. So under this interior field logic, the math of our 8-6-12 octahedron actually changes. It upgrades into a 9-7-13 model.
Let's walk through that.
You take the 8 outer faces and you add the center, the source face. So 8 becomes 9.
Okay.
You take the 6 outer vertices and add the center, the source vertex. 6 becomes 7.
Got it.
And you take the 12 visible outer edges and you add the hidden inner edge that connects everything. 12 becomes 13. You move from an 8-6-12 shell count to a 9-7-13 living field count.
Now, the math purist is going to scream that you can't just invent a new face in the middle of empty space. The center of an object isn't a literal flat panel you can touch.
And if you are only doing a shell count, the purist is right. But the center isn't an exterior piece of drywall. The center is the interior relational condition that makes the exterior possible. The 12 exterior edges of our shape are anchored and held in place by that hidden 13th edge.
Okay, so how does this 9-7-13 geometry map onto the actual physical geography of a watershed? Because when we apply this to the American breadbasket, the crisis suddenly comes into horrifying focus.
Yeah, it does. In this living geometry, the hidden volume, the core of the apple, the hidden 13th edge, is the aquifer. The exposed outer edge, the skin we can see, is the river.
Okay, and the regulating nodes that connect everything are the reservoirs, the charge that powers the system are the headwaters in the mountains, and the total body is the basin itself.
Exactly. So if you look at the Platte River during a drought, you drive over a bridge and you see a ribbon of dry sand. The immediate instinctual reaction is, oh, hasn't rained lately, the surface is dry.
You are making a shell count observation. You are looking at the skin of the apple.
Right. But armed with this 9-7-13 lens, we know that the dried up river is not a surface fact. It is the visible catastrophic collapse of inner pressure. The exposed edge is disappearing because the hidden volume beneath it, the aquifer, is collapsing. The center is failing to hold the boundary up.
Let's look at the actual patient lying on the operating table here. The Platte River and the Ogallala Aquifer system. The physical scale of this body is immense.
They're massive.
You have the North and South Platte rivers originating high up in the mountains of Colorado and Wyoming. They are the arteries pulling the charge down from the peaks. They flow eastward, converge in Nebraska, and push across the plains toward the Missouri River, eventually hitting the Mississippi and the Gulf.
And if you trace that on a flat map, it just looks like a one-way street discharging water into the ocean. But beneath that surface flow lies the High Plains Aquifer, commonly known as the Ogallala. It sits under parts of 8 different states: Colorado, Kansas, Nebraska, New Mexico, Oklahoma, South Dakota, Texas, and Wyoming.
Here's where it gets really interesting, though. When most people hear the word aquifer, they picture a massive subterranean cavern.
Yeah, they do.
Like a giant underground lake you could take a submarine through. But that's entirely wrong, isn't it?
It is a massive misconception. The Ogallala is not an underground lake. It is a vast, ancient, porous mineral body. It is billions of tons of sand, gravel, clay, and fractured rock. The water is trapped in the microscopic electromagnetic spaces between those grains. It is essentially an ocean of soaked stone.
An ocean of soaked stone. And we have been pumping that soaked stone dry for a century. The numbers from the United States Geological Survey regarding the depletion of this hidden volume are absolutely chilling.
They're hard to even comprehend.
Right.
From the era before modern agricultural development up to the year 2019, the USGS reports an area-weighted average water level decline of 16.5 feet across this entire 8-state subterranean body.
And a 16.5-foot drop translates to a staggering volume of actual water.
We're talking about a loss of roughly 286.4 million acre-feet of recoverable water in storage.
Let's contextualize that,
Because our brains struggle with numbers that large. An acre-foot is about 326,000 gallons. Multiply 326,000 by 286 million. You were talking about draining an inland sea.
yeah, an entire sea.
That is the hidden depletion of the interior body. The core of our 9-7-13 geometry is hollowing out.
And within this massive 8-state system, one state acts as the critical linchpin for the entire northern half of the body: Nebraska.
Nebraska.
The analysis refers to Nebraska as the hydrologic hinge.
Why Nebraska specifically? What makes it the hinge?
Well, it is the ultimate zone of convergence. It's the mouth-head interface. In Nebraska, you have the Sandhills, which are literally 20,000 square miles of highly permeable ancient sand dunes acting as a giant sponge.
Oh, wow.
You have the Platte River cutting directly over the aquifer. You have Lake McConaty, the massive regulating reservoir. And you have the arrival of the mountain snowpack melt from the west. All of these forces meet in Nebraska to intensely exchange water.
The hidden volume of the aquifer pushes water up into the visible river, providing base flow even when it isn't raining. And conversely, the river, the melting snow, and the rains seep down to recharge the aquifer. They are constantly trading fluids.
Exactly. So if that hinge breaks, if the pressure at that central interface fails, the underground body can't recharge.
Right.
The surface river goes dry, the reservoirs drain, and the entire northern half of the American breadbasket suffers a cascading system failure.
Which brings us to the agonizing reality of the year 2026. Because this isn't theoretical math anymore. That exact hinge is currently experiencing a catastrophic, snapped failure. Let's walk through the anatomy of this specific crisis, starting with the setup. The winter of 2025 into 2026.
Yeah, the winter really set the stage for structural dehydration. In Nebraska, from December 2025 through February 2026, the system just baked. It was the second warmest winter in recorded state history, with the warmest average high temperatures ever seen.
So the soil is hot, which increases evaporation, but it's also incredibly dry, right?
Very dry. It was the fourth driest winter on record. Much of central and western Nebraska, the very heart of that hinge we just described, received under half an inch of total precipitation across 3 entire months.
Less than half an inch. So the surface skin is completely parched. But the true terror begins when you look westward to the mountains, to the charge of our hydrologic circuit, the snowpack.
Right. Mountain snowpack is fundamentally a frozen reservoir. It's supposed to accumulate all winter, stay locked in ice, and then slowly melt and pay out dividends of water down the rivers just as the brutal summer heat hits the plains and the crops need it most.
But in March of 2026, the Nebraska State Climate Office looked at the snow water equivalent in the North Platte Basin, and their official assessment used 3 words that should terrify anyone who eats food. They said it had no modern analog.
It was completely off the charts. The snowpack was practically non-existent compared to historical norms.
Yeah.
Even the next worst year in the historical record had about 3 more inches of water equivalent.
That's a huge difference.
Massive. The storm tracks had shifted wildly north, and the anomalous heat meant that whatever snow did fall was melting aggressively early.
So the frozen bank account was being drained before the growing season even started. The charge is gone. Now look at the regulating node, the battery of the system. Lake McConaty.
Lake McConaty entered the 2026 season sitting at roughly 51% of its capacity.
Wow. Half empty.
Exactly.
That.
That is almost 30 percentage points below where it typically sits at that time of year. If you walk the shoreline, you are looking at vast stretches of dry, cracked mud where millions of gallons of water should be staged for the summer.
So if you are visualizing this 9713 body, your mountain snowpack is non-existent. Your primary reservoir is half empty before the heat even arrives. The soil over your critical hinge just endured one of the hottest, driest winters ever recorded.
Everything is depleted.
Both the charge and the battery are critically compromised before peak demand even hits.
And the geographic footprint of this failure is staggering. By mid-2026, roughly 94% of Nebraska, 96% of Colorado, and 98% of Wyoming are locked in drought. Colorado endured its 6th driest January through April. Wyoming, its 4th driest.
So the drought isn't just sitting over a few cornfields. It has blanketed the mountain source, the entire river transit corridor, and the massive receiving agricultural basin simultaneously.
This is why the diagnosis of structural dehydration is so vital. It isn't just a tough weather pattern. It is the whole body failure of the chug.
Now, human nature is incredibly resilient, but it also heavily relies on denial. I can hear people living in the Great Plains saying, look, 2026 is a bad year, but my grandparents lived through the 1930s. We survived the Dust Bowl. Drought is just part of the cycle here.
Sure, people say that all the time.
Right. So how do we contextualize 2026 historically? Is it actually worse than the Dust Bowl?
To answer that, we have to compare these droughts by their physical mechanics, not just by looking at rain gauges. We can't just ask which year had fewer inches of rain. That is a superficial shell count question.
Because it completely ignores the interior volume of the system.
Exactly. So let's look at 1934, the absolute peak of the Dust Bowl. Climate reconstructions over the last 1,000 years confirm that 1934 was the driest and most widespread drought in a millennium. It covered over 70% of western North America. Meteorologically, it was a monster.
But the analysis defines 1934 as an atmospheric/topsoil drought geometry. The severity of it was hugely amplified by human damage to the skin of the earth. We had ripped up all the deep-rooted native prairie grasses and exposed the raw topsoil.
Yeah, and when the rain stopped, the soil turned to powder. And that powder whipped up into the atmosphere, creating those apocalyptic black blizzards you see in historical photos.
Those photos are terrifying.
They are. And those dust clouds were so massive they physically blocked solar radiation from reaching the ground, which limited evaporation, which in turn prevented new rain clouds from forming. It was a devastating, human-engineered atmospheric feedback loop.
So in 1934, the surface was catastrophically destroyed. But what was the condition of the hidden volume? What did the Ogallala Aquifer look like during the Dust Bowl?
And that is the crucial distinction. In 1934, the High Plains Aquifer was practically untouched. We hadn't invented industrial center pivot irrigation yet.
Ah, right.
We weren't pumping millions of acre-feet out of the soaked stone to feed corn. Lake McConney didn't even exist yet. The vast buried interior volume of the patient was full, even though the skin was tearing apart.
Okay, so 1934 is the topsoil geometry. Let's fast forward. The source also looks at the drought of 2004-2006. How is that one categorized?
That period is defined as a managed storage drought geometry. In 2004, Lake McConney dropped to terrifying historical lows. But it wasn't strictly because the sky forgot how to rain. It was an infrastructure-driven crisis.
Right. Upstream groundwater pumping and new conservation measures were essentially capturing the water before it could ever reach the reservoir. The Platte River above the Kearney Canal was legally declared over-appropriated.
Right, over-appropriated.
Meaning we had mathematically assigned more rights to the water than there were actual drops of water in the channel.
Exactly. It was a crisis of an engineered basin. Then you look at 2012, which is categorized as a flash drought geometry.
A flash drought, the way it's described in the text, it acts like a giant atmospheric hairdryer.
That's functionally what happened. In the summer of 2012, right after historic flooding the year prior, a massive, persistent high-pressure ridge parked over the Great Plains. It combined incredibly high temperatures, zero rain, high winds, and intense solar radiation.
Yeah, it just baked everything.
It aggressively flash-boiled the moisture right out of the soil and the plants through evapotranspiration. It was a rapid, brutal atmospheric clampdown.
But the crucial difference is that the 2012 flash drought hit in the summer. It did not begin with the deep, systemic, winter and spring structural failure of the mountain snowpack that we are dealing with right now.
Which brings us back to why 2026 is its own terrifying beast. If we connect this to the bigger picture, the analysis calls 2026 a stacked compound geometry. It might not break the 1934 record for absolute lack of rain. It might not burn as fast as the 2012 flash drought.
But the danger lies in the context. We have the hot, dry winter. We have the catastrophic failure of the snowpack charge. We have the drained reservoir battery. Indeed, this is the lethal variable. All of this atmospheric pressure is striking a system where the deep hidden volume of the Ogallala Aquifer has already been chronically depleted over the last 80 years.
The internal buffers are completely gone. The immune system of the hydrologic body is compromised. This is why a moderate weather drought today can cause a total system collapse, whereas a severe drought 100 years ago was survivable.
It's structural dehydration. And this directly attacks the standard rebuttals that politicians and locals use to downplay the crisis. The material systematically guts these comforting illusions. Let's start with the most common one. Droughts have always happened. It's just weather.
The response to that is true and wildly insufficient. Yes, a drought is a weather event. It is a period of less moisture falling from the sky. But structural dehydration is the underlying condition of the physical system receiving that weather.
Let me use a human analogy again to explain this. Let's say a drought is like deciding to skip lunch today. If you are a healthy, well-fed person with plenty of fat reserves and a functioning metabolism, you skip lunch, your stomach growls, your body burns a little stored energy, and you're totally fine by dinner time.
Right, you survive.
That is a natural drought hitting a healthy hydrologic system.
But structural dehydration is what happens when you decide to skip lunch after you've been wandering aimlessly in the Mojave Desert for 3 days.
Yeah.
The exact same event, missing one single meal, is now a lethal trigger. because your internal hidden reserves are entirely gone.
Exactly. The weather event is the exact same, but the outcome is catastrophic because the volume has collapsed. Okay, rebuttal number 2. The Ogallala is massive. We have oceans of water down there. Nebraska sits on top of the deepest part of the pool. We are fine.
And again, the reality is true, but insufficient. The aquifer is massive. But immense size does not equal invulnerability. If you have a massive industrial battery and you are discharging its power 20% faster than you are recharging it, that battery is still dying. The sheer size of it just delays the inevitable blackout.
And as we established, Nebraska is the hinge. If the river flows drop and the central interface stops functioning, the fact that there is still water trapped deep in the bedrock doesn't mean the ecosystem is healthy.
In fact, that remaining deep water is the very last line of defense. It is precisely the volume that we must protect and replenish at all costs before it crosses a permanent threshold.
Which brings us to the third rebuttal. This is the absolute favorite of policymakers and municipal water boards. Conservation will save us. If we just mandate low-flow showerheads, rip out our lawns, and use hyper-efficient center pivot irrigation, we can fix this.
And here the analysis draws a brutally hard mathematical line. Conservation is absolutely necessary to slow the bleeding, but conservation alone is not restoration.
That is the core of it. Slowing a bleed does not put blood back into the patient's veins.
If the mountain snowpack is failing to accumulate, if extreme heat is skyrocketing the evaporation rates off the soil, and if the aquifer is already heavily drawn down, cutting your water usage by 15% is not going to magically generate millions of acre-feet of new water to refill the void.
Right.
You are just draining the tank slightly slower. The chug remains completely broken.
And if we don't fix the broken loop, the text warns of a very specific endgame. It uses the term functional aridification.
Yeah. We aren't saying the Great Plains will literally transform into the Sahara Desert overnight with massive sand dunes. But functional aridification means a permanent shift in the baseline. Lower groundwater tables, hotter ambient air, consistently lower base flows in the rivers, and a panicked perpetual reliance on reservoirs that can no longer fill up.
It's an extraction death spiral. Because the reality of modern agriculture is that we are essentially exporting our local water cycle. When a farmer uses groundwater to grow millions of acres of feed corn, that water doesn't stay in Nebraska.
No, it leaves the system entirely.
It is consumed through evapotranspiration, it is embedded in the physical grain, it is shipped on trains out of the basin, or it evaporates into the atmosphere and blows eastward to rain down on the Atlantic Ocean. We are literally mining the regional water body and shipping it away.
So if conservation is mathematically insufficient and we are structurally dehydrating the breadbasket, what is the actual solution? The source material pivots here from diagnosis to a staggering paradigm-shifting prescription.
So what does this all mean? This is where we get into the grand solution, and it completely blew my mind because of the sheer audacity of it. The core thesis is simple. For the last century, America built an unparalleled infrastructure of extraction. We built millions of wells, thousands of miles of concrete canals, massive dams, and municipal pipe grids, all of it designed to pull water out of the earth and move it to where we consume it.
But we utterly failed to build an equal corresponding infrastructure of return. We built a one-way street.
We broke the chug. So the solution proposed is what they call the continental return architecture. We have to physically engineer a system to push massive volumes of water back into the center of the country. We have to build modern aqueducts.
But the critical caveat here is that these cannot be extraction aqueducts in disguise. You cannot just drain the Great Lakes and pipe that water to the Ogallala.
Right, that doesn't solve anything.
You can't tap the Mississippi River to bail out the Colorado River. That is just shifting the extraction debt from one regional ledger to another.
To truly close the circuit, the system requires net new usable water. And there is only one place on Earth to find limitless net new water: the ocean.
The architecture demands a network of massive industrial-scale desalination hubs located on the coasts and the Gulf of Mexico. We take salt water and we purify it.
But I'm going to push back incredibly hard here because the logistics of this sound like science fiction. Desalinating ocean water is one thing, but Nebraska is 1,000 miles away and it's uphill. The energy required to pump millions of acre-feet of water against gravity across half the continent is mind-boggling. How on earth is this feasible?
You are raising the exact correct objection, which is cost and energy. The sheer thermodynamic lift is massive. The water would have to be moved via engineered, dedicated aqueduct corridors. We're talking massive pipelines or covered evaporation-proof canals requiring immense pumping stations all along the route.
And people constantly suggest a shortcut here. They say, wait, there is brackish, salty water deep underground right here in the Midwest. Why don't we just build inland desalination plants and purify that? It saves us the trouble of piping it from the Gulf.
And the analysis aggressively shoots down that shortcut. Inland brackish desalination does not provide net new water if that brackish water is drawn from within the same overarching continental bedrock system.
It's the same water.
Yes, you are just mining a deeper, saltier layer of the exact same collapsing volume. It might give a town drinking water for a decade, but it does absolutely nothing to restore the 9713 geometry of the region. You are just digging a deeper hole inside the dying body.
The phrase that perfectly captures the true goal of this mega project is aqueduct to the aquifer, not merely aqueduct to the faucet.
That is the ultimate paradigm shift. Our entire society views water infrastructure as a delivery mechanism for human consumption. But the continental return architecture views water infrastructure as a medical device to restore the environment itself.
So walk me through the mechanics of this. We pump desalinated Gulf water uphill to Nebraska. How does it actually get back into the broken volume?
Through an array of return mechanisms. Midpoint recharge basins, which are massive, engineered lowlands designed to let water slowly percolate down into the gravel, deep injection wells, which physically pump water deep into the subterranean bedrock where the geology allows, managed floodplain restoration. We're actively forcing net new water back into the hidden 13th edge.
We are artificially closing the loop of the chug. Some of the water gets routed to stabilize failing reservoirs like Lake McConney. Some of it is released as ecological base flow to ensure the Platte River doesn't turn into a dry sand ditch. The point isn't immediate consumption. The point is restoring the circulatory pressure of the entire region.
Right. Now, let's return to your pushback about the sheer scale and cost of this. Pumping ocean water to the Midwest sounds insanely expensive. The energy grid required to run the pumps would be astronomical.
Exactly. It sounds like a multi-trillion-dollar pipe dream. It's the Hoover Dam, the interstate highway system, and the Transcontinental Railroad all combined.
And the material offers a final, unassailable justification for the cost. Yes, the continental return architecture is staggeringly expensive, but what is the financial cost of losing the American breadbasket?
What is the price tag of the collapse of the global food supply?
Exactly. If the Ogawa fails, the economic engine of 8 states collapses. Global grain markets destabilize. The resulting economic, social, and political devastation would make the cost of a pipeline network look like a rounding error. As the text reminds us, the aqueduct is an ancient, permanently intelligent idea.
The Romans built them.
The Romans built them. California built them. Civilizations endure only when they recognize that water must be moved from places of absolute abundance to places of structural need and then actively stored.
We just have to evolve our engineering to match the terrifying scale of our extraction. We have to build a continental cardiovascular system.
We have to manually close the jug.
We have covered a staggering amount of ground today. We started by ripping up the comforting illusion of the flat, two-dimensional map. We zoomed into the quantum probability clouds of hydrogen, explaining how the polarity of a water molecule and the Gertzenstein coupling of electromagnetism and gravity prove that reality is a living, unified field.
We threw out standard math and embraced the 9713 interior field geometry, learning that you cannot measure a system's health without understanding its hidden core. We mapped that core onto the High Plains Aquifer, identifying Nebraska as the fragile, critical hinge of the system.
We dissected the horrifying stacked vulnerability of the 2026 drought, comparing its structural dehydration to the topsoil failures of the Dust Bowl, the managed storage crisis of 2004, and the flash burn of 2012. We proved that starving the patient makes the weather infinitely more dangerous.
We dismantled the myth that conservation alone can magically generate new water. And finally, we explored the massive existential necessity of building a continental aqueduct system to pump desalinated ocean water back into the dying heart of the country.
It is a profound, almost dizzying shift in perspective. And to you, listening right now, I want to leave you with this final, tangible thought. Tomorrow morning, when you turn on your kitchen tap to fill up your coffee pot, or the next time you see a news clip of a dry, cracked riverbed out west, I want you to remember that you are only looking at the very edge of the shape. You are looking at the shell face of a massive, hidden, volumetric body that is holding up the lives of millions.
You are looking at a chug, a living, breathing, pressurized circuit that is begging us to close the loop before it collapses entirely.
This deep dive fundamentally redefines management by proving that you cannot build a healthy, enduring civilization entirely on the geometry of extraction. You must have a built-in architecture of return. It's a law of physics. And it leaves you with a haunting question. If we got this so deeply, dangerously wrong with the very water that keeps us alive, what other massive foundational systems in our modern society, from our financial markets to our energy grids to the very nutrients in the soil that grow our food, are we currently treating as straight, endless lines of extraction, completely blind to the fact that we are breaking the chug? Think about that.